Hi everyone. In this video, let us see the relation between zeros and coefficients of a polynomial. The general form of a linear polynomial. The general form of a linear polynomial is ax plus b. The zero of this polynomial is minus b by a. So here the zero is minus of constant term by coefficient of x. So the constant term the constant term b can be written as b is equal to b into x power 0. So the constant term can also be considered as coefficient. So constant term, this is coefficient of x power 0. So here for linear polynomial, we have a relation between 0 and the coefficients of the linear polynomial. 0 of linear polynomial is equal to minus of constant term by coefficient of x. Let us see what is the relation between zeros of a quadratic polynomial and the coefficient of the polynomial. Let us take one quadratic polynomial and observe what is the relation. For example, 2x square minus 8x plus 6. This is a quadratic polynomial. Now let us find zeros. What are the zeros? We have to equate this to 0 and solve for x. Then we can find zeros. So before that, let us factorize this quadratic polynomial. 2x square minus 8x plus 6. So this can be factorized by splitting the middle term. Middle term is minus 8x. This should be split into a sum of two terms. The sum of the two terms should be minus 8x, and product of those two terms should be equal to product of 2x square and 6. So first take the product of 2x square and 6. 2x square and 6, the product is 12x square. So we have to split minus 8x into two terms whose product is 12x square. So we can do it by taking only the coefficients. Let us say 2 into 6 is equal to 12 here. Let us take the factors of 12. When divided by 1, we get 12. So 1 into 12. If we add these two, we are getting 13. So these are not our choice. Then when divided by 2, we get 6. 2 plus 6 is 8. But we have negative 8 here, minus 8x. So we have to take minus 2 minus 6. So minus 2 into minus 6 is 12. Minus 2 plus minus 6 is minus 8. So this can be split as 2x square minus 6x minus 2x plus 6. So here we have written minus 8x as minus 6x minus 2x. Let us consider these two as one group, these two as another group. Let us take the highest common factor, 2x. 2x is the highest common factor here. By taking 2x as common, we remain with x minus 3. So here again, we can take minus 2 as common. Minus 2 as common factor. Taking minus 2 as common factor, we remain with x here and minus 3 here. So in these two groups here, x minus 3 is a common factor. Now taking x minus 3 as common factor, we get x minus 3 into 2x minus 2. And here in 2x minus 2 also, we can take 2 as a common factor. So this becomes x minus 3 into 2 into x minus 1. This is equal to 2 into x minus 3 into x minus 1. Now we have written our quadratic polynomial as a product of two linear polynomials. When we equate this one to 0, 2 into x minus 3 into x minus 1. Let us equate this to 0. Now either x minus 3 should be 0 or x minus 1 should be 0. From this we get x is equal to 3 or x is equal to 1. So x is equal to 3 or 1. 3 and 1. These are the zeros of the quadratic polynomial. Polynomial 2x square minus 8x plus 6. The zeros we got are 3 and 1. 3 and 1 are the zeros. And here we have the polynomial as 2x square minus 8x plus 6. The coefficients of the polynomial are 2, minus 8 here, 6 here. 6 is a constant term, so it is also a coefficient. Now let us see sum of zeros. Sum of zeros. The zeros are 3 and 1. So 3 plus 1, we get 4 here. So how can we get 4 from these coefficients? From these coefficients, we have here minus 8 and 2. 8 by 2 is 4. So minus of minus 8 by 2. So sum of zeros can be written as minus of minus 8 by 2. So this minus 8, so this is minus of minus 8 is coefficient of x. By 2 is coefficient of x square. 2 is coefficient of x square. So what is the relation we have got for what is the relation between zeros and the coefficient of quadratic polynomial? Sum of zeros. Sum of zeros is equal to minus of coefficient of x by coefficient of x square. Then now let us take product of the zeros. What is the polynomial? Polynomial is 2x square minus 8x plus 6. The zeros are 3 and 1. 3 and 1 are the zeros. Let us take product of the zeros. Product of the zeros is 3 into 1. It is 3. Then observe the coefficients. Then observe the coefficients of the polynomial. The coefficients are 2, -8 and 6. How do we get 3 here from the coefficients? So we get 6 by 2. 6 by 2 is 3. So what is 6? 6 is constant term. Constant term by 2 is quotient of x square. Now what is the relation we got here? Product of zeros. Product of zeros. Product of zeros is equal to constant term by quotient of x square. So the relation we got, so the relation we are getting here is sum of zeros. Sum of zeros is equal to minus of coefficient of x by coefficient of x square, and product of zeros is equal to constant term by coefficient of x square. This is the relation between zeros and coefficient of quadratic polynomial. What is the general form of quadratic polynomial? Ax square plus bx plus c. So we can take alpha and beta as the zeros of the quadratic polynomial. This is alpha. Alpha and beta are Greek letters. This is pronounced as alpha and this is pronounced as beta. For a cubic polynomial, we will have at most 3 zeros. Then we can use one more letter, gamma. So alpha, beta and gamma are used for cubic polynomial. Here we have only 2 zeros for quadratic polynomial. We are using alpha and beta. So this is gamma. Alpha, beta and gamma are Greek letters. Now let us write the relation using alpha and beta and also a, b, c, which are the coefficients of ax square plus bx plus c, the quadratic polynomial. So sum of zeros, so alpha plus beta is equal to minus b by a. Here minus of coefficient of x by coefficient of x square. Coefficient of x is b. Coefficient of x square is a. So alpha plus beta is minus b by a. Then what is alpha into beta? Product of zeros. It is constant term by coefficient of x square. So this is c by a. Alpha into beta is c by a. Alpha plus beta is minus b by a. Alpha into beta is c by a. Now let us take some examples and check whether this relation holds good. Say p of x is equal to x square minus x minus 6. Let us find zeros. Before equating the polynomial to 0, let us split the polynomial into two linear factors. Here we have 1 as coefficient of x square. The constant term is minus 6. So 1 into minus 6 is minus 6. We have to take the factors of minus 6 whose sum is minus 1 here. Minus 6 can be written as 1 into say 6, somewhere negative here. This one is negative or this one is negative. The sum of 1 and minus 6 is minus 5. So we are not getting minus 1. So take 2 and 3. 2 and minus 3. 2 into minus 3 is minus 6. 2 plus minus 3 is minus 1. So we can take these two factors. Now this one can be written as x square plus 2x minus 3x minus 6. Out of these two terms, x is a common factor. So taking x as a common factor, we remain with x plus 2. Out of these two terms, minus 3 is a common factor. So minus 3 into taking minus 3 as common factor, we remain with x plus 2. In these two groups, x plus 2 is a common factor. So taking x plus 2 as a common factor, we remain with x minus 3. Now we have factorized quadratic polynomial into a product of linear factors. P of x is equal to 0 implies x plus 2 into x minus 3 is equal to 0. So it implies x plus 2 is equal to 0 or x minus 3 is equal to 0. So this gives x is equal to minus 2 or x is equal to 3. So minus 2 and 3, minus 2, 3 are zeros of what is the polynomial x square minus x minus 6. X square minus x minus 6. Now let us see. The zeros are alpha and beta. So alpha is equal to minus 2. We can take the either way also. We can consider minus 2 as beta, minus 2 as beta and 3 as alpha also. Now what is alpha plus beta? Sum of the zeros, alpha plus beta is equal to minus 2 plus 3. It is positive 1. The relation between zeros of the quadratic polynomial and the coefficients of the quadratic polynomial is alpha plus beta is equal to minus b by a. Alpha into beta is equal to c by a. Now we have got alpha plus beta is equal to 1. So what is minus b by a? Minus b here is minus 1. A is 1. C is minus 6. So minus of b by a. Minus of minus 1 by a is 1. Minus of minus 1 by 1. Minus of minus 1 is 1. 1 by 1 is equal to 1. So here we are getting alpha plus beta is equal to minus b by a. We have verified this relation. Then another relation, alpha into beta, product of zeros alpha into beta is equal to minus 2 is 1 0 and another 0 is plus 3. Minus 2 into plus 3 is minus 6. What is the relation? We have got alpha into beta is equal to c by a. Now let us see what is c by a. Value of c is here minus 6. So minus 6 by a is 1. Minus 6 by 1. This is minus 6. So we have verified the relation alpha into beta is equal to c by a. Product of the zeros is constant term by coefficient of x square. In this way we can verify the relation for any quadratic polynomial. Let us see how do we get this relation algebraically. Say alpha and beta are zeros of quadratic polynomial. Then how do we write the quadratic polynomial? The zeros are given, zeros are alpha and beta. Then how do we write a quadratic polynomial? The linear polynomials are x minus alpha. As alpha is 1 0, x minus alpha is a linear factor of the quadratic polynomial. Another linear factor of the quadratic polynomial is x minus beta. When we take the product of these linear factors, we get quadratic polynomial. But even if we multiply this by any constant, we will get the same zeros. So the polynomial here is k into x minus alpha into x minus beta. So this is our polynomial. Let us expand this one. K into here x into x, x square, then alpha into minus alpha into x and minus beta into x. Here we get minus alpha into x and minus beta x. Then minus alpha into minus beta is plus alpha beta. This becomes k into x square. Here x term can be simplified as minus of alpha plus beta into x plus alpha beta. We have taken alpha beta as zeros. We have written the polynomial having zeros alpha beta. The polynomial having zeros alpha beta is k times x square minus alpha plus beta x plus alpha beta. Let us compare this one with the general form of the quadratic polynomial. The general form of quadratic polynomial is ax square plus bx plus c. Now when we compare, a is equal to k and b is equal to, here what is the b? The coefficient of x. So b is equal to this minus k here, k into alpha plus beta. Then c is k into alpha beta, k alpha beta. Then from this, let us take alpha plus beta. What is alpha plus beta? So here alpha plus beta is equal to b minus b by minus k. Alpha plus beta is b by minus k. Alpha plus beta is equal to b by k is equal to a. So minus a. When we write it, when we write the fraction in simplest form, we can take the negative to numerator. So alpha plus beta is equal to minus b by a. Then let us take alpha into beta. What is alpha beta? Alpha beta is equal to c by k. Here k is equal to a. So alpha into beta is equal to c by a. So here we have shown again algebraically alpha plus beta is equal to minus b by a. Alpha into beta is equal to c by a. Here we have to observe one thing. Initially we have taken the polynomial 2x square minus 8x plus 6. This was split into 2 into x minus 1 into, so this is 2 into x minus 1 into x minus 3. So the zeros are x is equal to 1 and 3. So here we have got a factor, a multiplier. Let us say this is k. So even if we take x minus 1 into x minus 3 as our polynomial, we will have zeros 1 and 3. That means, see, x square minus 4x plus 3. This has zeros 1 and 3. Any polynomial in this form, some k times x square minus 4x plus 3 will have the same zeros 1, 3. So there are infinitely many number of polynomials with the given two zeros. Given zeros 1, 3, we can write infinitely many number of polynomials. They are k into x square minus 4x plus 3. So we can write, if we take k as 1, that is x square minus 4x plus 3. If k is 2, this is for k is equal to 1. If k is equal to 2, we get 2x square minus 8x plus 6. Say if k is equal to 3, we get 3x square minus 12x plus 9. If k is equal to something, we will get another polynomial. All these polynomials have same zeros 1, 3. See you in next video.